Hi everyone, good day. Today I'll be having a technical talk with you on Inside SSRF, dissecting, defending against server-side request forgery and web application. I'm Gloria Asuquo and I am a cybersecurity analyst. The paradigm of retrieving information resources from the web services through user URLs has become a common factual feature of modern web applications. Those features are facilitated by server-side requests utilizing HTTP requests generated by servers for inter-servers communication. Numerous and popular web applications such as WordPress, Joomla utilize SSR for diverse functionalities such as loading remote images or as avatars or downloading plugins. However, this widely adopted SSR mechanism is susceptible to server-side request forgery vulnerabilities. What is SSRF? SSRF is a vulnerability that lets a malicious hacker send a request from the back end of the software to another server or to the local service, which is like the bad guy server. This is how it works. How it works is that how it works is that the server thinks the request is legitimate. When the developer sends a request, the server thinks that this request is legitimate because it originates internally. But an attacker comes and interferes between the interaction and then controls the server, which goes on and controls what it fetches. So this is how it works. A developer sends like for example, let's look at it from the standpoint. A developer sends a robot to myfriend.com, but the bad guy is like, no, come, let's go to badguy.com. And because the robot is not able to properly verify where it is originally being sent to, it is being redirected to badguy.com. Why does SSRF matter? It matters a whole lot. First, because it's the only vulnerability with its own category in the OAP's top 10 2021 list. Additionally, it has been listed among the 25 most dangerous and common software vulnerability on the CWE top 25 by Metro. Another thing is that it has a high impact because the attack originates from inside the trusted boundary. So because it's generated from inside, it's sometimes very difficult to trace. Yeah. How does SSRF work? Number one is that when you build a network software, you often need to make requests to other servers. Developers typically use them to fetch remote resources, such as software update or to import metadata from another application. Such requests are not dangerous at all, but if implemented incorrectly, they can make the software vulnerable to the server-side request forgery. Another thing is that an SSRF vulnerability can be introduced when you use user input data to create a request. To perform an SSRF attack, an attacker can then change a parameter value in the vulnerable software to create or control requests coming from the software and that goes to other servers or even the same servers. So attackers tweak a parameter to redirect the server from the servers to the internal system, the external malicious servers, or even the local or cloud metadata endpoint. It also this vulnerability may appear in any type of computer software in almost every programming language and on all platforms as much platforms as possible as long as the software works in a networked environment. um the consequences of server-side request forgeries are enormous. They are enormous, but For the purpose of this talk, I'm going to be streamlining them to just a few. Number one is that it has unauthorized access to internal systems. Um, this one of the top consequence of SSRF, its unauthorized access to internal systems. Number two is exposure of sensitive information housed on the internal system. Number three, SSRF can also enable denial of service attacks when intentional requests overwhelm systems or components within the network. SSRF can also enable denial of service attacks where intentional requests overwhelm system or component within the network. Think of SSRF like tricking a robot messenger into repeatedly knocking on someone's door non-stop. Then if an attacker tells the server, that's the robot, to send a huge number of requests to another system inside the same network, that system can become overwhelmed and stop responding. That's how the denial of service works. So instead of just stealing data, SSRF can be used to flood internal systems with traffic, causing them to crash or to become slow. Use of SSRF to disguise the origin of attack. SSRF can hide where the attacker really comes from. Normally, an attack comes from the hacker's computer, but with SSRF, the attacker uses your server as the face of the attack. That means that malicious request is sent by your server and not the attack. Imagine. Also, logs shows your organization's IP address and not the attacker's IP address. It's like forcing someone to commit a crime they are not inside of. It's like imposing someone or accusing someone of a crime that they are not responsible of. Also, malicious attacks that appear to originate from the organization hosting the vulnerable site, causing reputational damage and legal liabilities. The SSRF can make attacks look like they came from inside the company. Because SSRF makes your server send the request, it may appear that a trusted internal employee or trusted internal system performed the malicious action, and this can lead to reputational damages, your system attacked by another organization, or even legal liabilities, that is you being blamed for actions you didn't perform and then being taken to court for it. Security confusion, where it looks like your own servers are the one causing the one causing the own attack, and it's from your own network. And if it makes the victims organization look guilty when actually they're just being used like a puppet. Direct detection of server-side request forgery. Number one, input-based discovery. You have to review the application for any input field or functionalities that requires an external resource fetch. Examples could be URL fields, file upload functions, or image fetch functionalities. Manipulate this input to provoke abnormal behavior, such as entering an internal IP or local host in a URL field. Number two is code analysis. SSRF functional vulnerabilities can exist in application code that makes external requests on the user's behalf. Code implementing like uploads, webhooks, and similar functionalities should be scrutinized for potential vulnerabilities and have controls put in place. So try as much as possible to go through um go through your codes and ensure that you take analysis over time to ensure that you're able to detect for any SSRF vulnerability. Um, use of security testing tools. SSRF vulnerabilities appears in any application security code, and its um and its behavior during testing. As a result, both static and dynamic application test security testing tools can aid in vulnerability testing. So as long as they are in any application source code, and you can use or make use of application security testing to aid your vulnerability detection. Also, we have traffic monitoring. A successful SSRF exploit involves a web application making requests to unusual and potentially dangerous URLs. An intrusion detection system can detect or alert an attempted exploitation of these vulnerabilities. So, using an IDS should be part of your detection techniques in finding out for SSRF vulnerabilities. Use of security tools like such as Bob suite. So using of Bob suite can go a long way in detecting for these vulnerabilities. Um, what are the ways of preventing server-side request forgery attacks? Number one is to whitelist or um, any domain that your application accesses. The server should not respond to unpredicted, unformatted data directly to the user's browser or app. Instead, the server should only send structured, safe, expected data um, that the client already knows of. Number two, never send a raw response body from the server to the client. It's just like going to a restaurant and ordering for pasta. You don't expect the chef to scoop it from directly from the pot straight to your hand. He's meant to serve it to you in a plate. So never send a raw response body. Try as much as possible to package it properly. We also have number three, which is allow only URL schemas. If you're not using FTP file or the HTTP enabled, if you're not using any of these things, you should try as much as possible to do away with them. Only use the one you're using, which is like for example HTTPS. Then number four, enable authentication on any service that's running inside your network, even if they don't require it. Validate and sanitize all users' input. Finally, try to adopt a zero trust approach to any user controlled URL that you come across. It's very important not to make assumptions and to make excuses for your security. Finally, we come to the end. But before we go, SSRF hides inside normal server behavior. We should have that in mind. SSRF is powerful because the attack uses internal trust. It is easy to introduce but preventable with validation, filtering, and proper access control. Can be detected through input testing, code review, and monitoring. That brings me to the end of my show. But please, if you do have any question, do not hesitate to contact me through my email, gloriaesco@gmail.com, or send me a LinkedIn DM at Gloria Asuquo, and I'll be so happy and pleased to attend to every question you have. That brings me to the end of my technical talk, and I hope you understand more on SSRF attacks. Thank you so much, everyone. Dalu, Meda Wase, Sosongo. Bye, guys.